In this video, we're going to learn how to calculate a confidence interval for a single proportion. What we're going to do is take a sample and get a sample proportion, and then from that sample proportion, we are going to calculate a range of values that we can be confident the actual population proportion falls between. So again, a confidence interval the range of values in which we're confident that the population proportion will be in. So just a quick reminder, sample proportion, or p hat, equals x divided by n. Sample proportion is considered a point estimate. That's a phrase that you'll see in different problems. So point estimate is the sample proportion. A sample proportion is an unbiased estimate of a population proportion. We learned a little bit about that earlier, where the distribution of the population, or the distribution of the sample proportions is a normal distribution. That means it's unbiased. We can use the sample proportion to calculate a confidence interval for estimating the population proportion, and the sample size will be important and affect our accuracy. Also, a quick reminder about proportions. They are between 0 and 1. So if you're given percentages, you need to convert it into decimal. Make sure that you're moving the decimal place the correct number of times. And if you're doing any of these problems and you get a number that's bigger than 1, check your work, because you probably made a mistake somewhere. All right, critical values are z-scores for proportion problems. They're going to provide some level of alpha. And in confidence intervals are always two-tailed. We're kind of looking for a range of values that something is between, which leaves out the tails on both ends. So we always use alpha over 2 for finding our critical values of z. If you remember from a previous set of notes, we have lots of different values for the critical z for confidence intervals, and you can see they're all here. And then we have alpha. If alpha is just given to you, say they give you alpha equals 0.05, then you would use a z of 1.96. If they give you a confidence level, say you want a 99% confidence interval, that would be 0.99 for your confidence level, and then you'd come across and use 2.575 for your critical z, or z alpha. Okay, so let's move down a little bit here and get to some actual calculations. The margin of error is what we're going to use to calculate a confidence interval. And the equation, margin of error, E, equals our z that's based on the confidence level that we're given, times the square root of p hat times q hat divided by n. And we're going to use 3 significant digits for E. That means 3 numbers other than 0. So if we get, say it ends up being 0.00436228, something like that. 3 significant digits, these don't count, but these do. So there's 1, 2, 3. That's the digit we'd round to, and then we would just drop the rest of that. So this is a number that has 3 significant digits. Then we're going to express the confidence interval as the sample proportion plus or minus the margin of error, which ends up being the sample proportion minus the margin of error for the low number in the range, to the population, or the sample proportion plus the margin of error, which gives you the higher number of the range. So this one should be the low number, and this one should be the higher number. Okay, so let's do an example. It says we have a sample of 500 people, so that's our sample size, n. 220 of them have brown eyes, so x is kind of like the number of successes or number of things we're looking for out of n. And we want a 99% confidence interval, so our confidence level is 0.99. So for our margin of error equation, we need z alpha over 2, we need p hat, we need q hat, and we need n. The n's given to us in the problem, 500. P hat equals x over n. We have 220 people with brown eyes out of 500, which would give you 0.44. Q hat is 1 minus p hat, or 0.56. And then the z for alpha over 2 for a confidence level of 99%. If we were to look that up in the table I just had up, you'd get 2.575. So those are all the numbers we need. Now we can plug them into the equation. So E equals Z alpha, and then we have 0.44 for P hat, 0.56 for Q hat, 500 for sample size. I encourage you to do this in steps and write down all your steps instead of just trying to plug it all into your calculator at once. And when you calculate that, we get a margin of error equals 0.0572. That has 3 significant digits. Okay. But we're not done. All we have so far is the margin of error. We don't have a confidence interval yet. So in order to get the confidence interval, we need to use the format p hat plus or minus e. So p hat was 0.44, and the margin of error is 0.0572. So we subtract first. 0.44 minus 0.0572 will give you 0.3828. That's the smaller number. And then the bigger number would be 0.44 plus 0.0572, which would give you 0.4972. That's a confidence interval. Okay. So you can report it this way, which is a common way. You could have leave it like this if you wanted to. That's another format for a confidence interval. I prefer the one with the small number and the big number, so you have the full range of values for your confidence interval. Our calculator can do the same thing we just did, calculate a confidence interval for a single proportion, but in a lot faster. So let's bring up a calculator and see how to do that. So in the calculator, in your Stat menu, go over to Tests. And we're doing a confidence interval for a single proportion. So that's a 1 proportion Z interval. And it's letter A and the TI-83. So 1 prop Z int. And hit enter. So you can see that I already put the values in. So in that problem, X was 220 people with brown eyes. N was 500 total people. The confidence level is 99% or 0.99. And you go down to calculate and hit enter, and there's our confidence interval, 0.3828 to 0.4972, exactly what we got by doing the equation by hand. Okay, so again, the calculator provides you a shortcut, but hopefully you understand the method and what it means by using the equation. Another application of the confidence interval equation is we can rearrange the equation and solve for n. So if we want to do a confidence interval with a particular confidence level and work toward a particular margin of error, this is especially important for people who do polls and surveys. They want a particular margin of error when they're done. They can figure out how many people they need to ask that question or include in their sample in order to have a result for a particular margin of error. So the two equations are here, and let's go down and do an example of sample size. I'll leave the equation here. Alright, so first thing we need to do is find all the values we need for a sample size equation. So in the problem, we want a margin of error, E equals 3%. We can't use 3% as E, we need to convert it to a decimal. So when you're doing problems for class, make sure that you change a margin of error in a percentage to a decimal margin of error. They give us a confidence level of 95%. They give us a sample proportion, which is p hat, which would be 0.87. And it's asking how large of a sample do you need. And that's our sample size, n, which is what we're trying to find out. So we need a z, we need margin of error, we need p hat and q hat. They gave us p hat in the problem, 0.87. And p and q have to add up to 1, so 0.13 for q hat. They give us the margin of error, 0.03. And z for alpha over 2, if we bring that table back up, we want a 95% confidence interval. So for a 95% confidence level, follow that over, we need to use 1.96 for z. Okay, now we can plug all of those into our equation. So the equation is our z score squared times p hat, which is 0.87, times q hat, which is 0.13, divided by the margin of error squared. And again, I encourage you to do this in parts in your calculator. So let's just do the top part. You get 0.4345. 0.03 squared is 0.0009. And then when you divide that, we get 482.76. But remember, this is sample size. We need whole numbers. You always round up, no matter what the decimal place is. Or always round up. So that is a sample size equation. Again, something that they would do a lot if they're doing surveys and polls, to find out how many people you need to ask so that you have a certain margin of error when you're done. So some common errors to avoid: don't use alpha in the value instead of z. Make sure that you use alpha to find the z that you need for the equation. And if e is given to you in a percentage points, convert it to a decimal. So if you get 3%, change it to 0.03. If they tell you e equals 3, then just leave it as 3. It's not 3%. Right. Other equations. If you have a confidence interval, so if you have your confidence interval like this, what you would do to figure out what the center value is you can just add those two together and divide them by 2. And then you'll get the middle, which is what the sample proportion is. So your upper limit plus the lower limit divided by 2. And if you want to do the margin of error, the e, you would subtract them and divide by 2. So upper limit minus the lower limit divided by 2. So we have a confidence interval here as an example, and we want the sample proportion, p hat, and the margin of error, e. So we can do 0.85 plus 0.77 divided by 2. And when you calculate that, you should get 0.81. Margin of error, we're going to subtract the 2. And we should get 0.04 for that. So then if you want to put it back in the format p hat plus or minus e, there's our numbers, and you can see that when you do 0.81 minus 0.04, you get the lower number, 0.77. And if you did 0.81 plus 0.04, you get the bigger number, 0.85. So you've checked your work and you know you got it right.